Knowing how to determine the x and y intercepts is going to help you on several fronts on the SAT. First, on occasion they do want to know what the x-intercept is or the y-intercept, but it's also a way of working with some of the functions, some of the graphs that they give you. Now remember, to determine the x and y-intercept, you have to think a little bit crossways. If you set x equal to 0 and y equal to 0, you'll find the x and y-intercepts. But if you set x equal to 0, that gives you the y-intercept. That shows you where the x value is 0. That's where the line is going to cross the y-axis. Concomitantly, when you set y equal to 0, that shows you where the line is going to cross the x-axis. It's a little bit backwards, but once you realize it's that way, it's easy to remember. Now we're going to deal a little bit with abstractions. When we say abstractions, these are the type of problems where they give you variables or they give you something not concrete. In most cases, you're going to want to substitute numbers in order to make these things make sense. Let's look at an example. Let's say they give you a problem that says a drill bit is used by an oil company that will last for n feet. If each hole is q feet deep, how many drill bits are needed for x holes? Alright, there are no numbers here. And I don't know about you, but I don't like flipping around n and q and x. It's hard for me to keep track of it. So let's give these things value. Let's say that n, the number of feet a drill bit will last, is 100 feet. And let's say that each of these wells is q, or 300 feet deep. And we want to do 4 wells. Well, you just divide 300 feet by 100 feet to find out how many bits you're going to need, wouldn't you? And so you need 3 bits per hole. If I'm going to do 4 wells, that's 3 times 4. So now let's just substitute the letters back in for the numbers. Q goes where the 300 feet is. N goes where the 100 feet is. And you multiply that by x. So that's going to give us qx over n. Put numbers in there so you can make these things make sense. Remember, if you have a split numerator, that denominator applies to both the numbers in the numerator. In this case, if I've got r plus n over r, that separates to be r over r plus n over r. R over r is 1, so our solution to this would be 1 plus n over r. Remember, when you see a split numerator, and you'll see that a good bit on the SAT, remember when you see a split numerator, you have to apply the denominator to both the numbers in the numerator. The SAT is very fond of asking you questions about overlapping groups. The key to solving these is to get the numbers out of the words and account for the overlapping groups. In this case, there are 78 students taking math class. There are 102 students enrolled in science. 46 students take science and math. How many students are attending the 2 classes? The math is easy as long as you have the reasoning to back it up. First, we want the total in the classes. We've got 78 and 102, so there's 180 students enrolled in these 2 classes. But there are 46 that overlap, are in common. So we subtract that from the 180, we find out there are 134 students, actual students in the 2 classes. The SAT loves to give you fractions within fractions. If you have a fraction in the numerator, it's really pretty simple. It just drops down. In effect, if I've got 1/4 over 3, I'm just looking for 1/3 of 1/4, which is 1/12. They're much more likely to give you a fraction in the denominator. In this case, 3 divided by 1/4. Remember, when you have a fraction in the denominator, what you do is multiply the numerator by the reciprocal of the denominator. The reciprocal is what you would multiply that number by to get 1. In this case, the reciprocal of 1 over 4 would be 4 over 1. So we're multiplying 3 times 4 over 1, 12. They'll give you a pretty simple problem like this. At first glance, it looks easy, but you've got to remember there's a trick to it. You've got to remember to round up. Okay, in this case, if it takes 1 gallon to paint 8 square feet of wall, how many gallons are needed to paint 4 walls, each measuring 11 by 9 feet? Okay, your first step, get the numbers out of the words. And getting the numbers out of the words, each wall is 11 by 9, so each wall is 99 square feet. We got 4 walls, so 99 times 4 is 396. We want to know how many 8s are in there. So 396 divided by 8 gives us 49.5. Okay. Remember, if you've got half a gallon, you've got to have a whole gallon to have that half. So you've got to, in this case, round up. You've got to have 50 gallons. The SAT will also ask you for remainder problems. These are problems to determine if you know that there's actually a number left over when you divide one number into another, not just decimals. One way they ask you for a remainder problem is going to be to have you make your calculations using your calculator and see if you can determine that those decimals really mean a number. In this case, we're reducing the number of classes from 28 to 25 but keeping the same number of students. So we want to find out how many students we have in these 28 classes, each with 22 students. So we multiply 28 by 22, gives us 616 students. We now divide the 616 by 25, leaving us 24.64. That 0.64 is 0.64 or 64% of 25. That gives us a real number of 16. They can also come after you in a more abstract fashion, as in this case where they say x when divided by 5 leaves a remainder of 2. What would be the remainder when 3x is divided by 5? Well, simply pick a number that fills the requirements. We want a number that leaves a remainder of 2 when divided by 5. 7, 12, 17, something like that. Let's pick the smaller one. 7 times 3 is 21. When you divide that by 5, it leaves a remainder of 1. You'll see sequences on the test, 2 types of sequences. The first type, an arithmetic sequence, simply follows a pattern where you're adding a number to each term before it. For instance, here we're looking for the 23rd term in the sequence 4, 7, 10, 3. Well, we can see from the sequence that you're simply adding 3 to each number before it. And you determine the nth term in that sequence by multiplying 3, because that's what you're adding to each term, by n minus 1. You use n minus 1 so that you don't count that first term. So this problem would be solved with the formula 4, the first term, plus 3, the unit that you're adding to each term, by 23 minus 1. You've got 23rd term you're looking for, and you've got to get rid of that first one. Therefore, you've got 4 plus 3 times 22, which is 4 plus 66, or 70. You can also encounter a sequence which involves geometric or exponential growth. Now, this is a sequence which involves a ratio between consecutive terms. You might find this in a population type problem, for instance, or one like this, where you have a sequence of 3, 12, 48, 192. What would be the value of the 8th term? Well, first we have to determine the ratio. 12 divided by 3 is 4. 48 divided by 12 is 4. 192 divided by 48 is 4. So our ratio is 4. Once we've determined that our ratio is 4, we now apply that to the formula of 3, the first term in the sequence, times 4 to the n minus 1. Again, the n minus 1 eliminates that first term. That takes us then to 3 times 4 to the 8 minus 1, or 3 times 4 to the 7th, which is 3 times 16,384, which gives us a final value of 49,152. There are 2 types of variation problems that you'll see on the SAT. If numbers vary directly, they have a common factor. By that I mean if y equals kx, where k is a constant, and concomitantly y over x equals a k constant, then you can say that these 2 numbers vary directly. For instance, if y equals 4x, you then just follow it. If y is 8, x is 2. If y is 12, x is 3. If y is 32, x is 8. Numbers vary inversely if the product of the 2 variables is constant. For instance, x times y yields k, a constant. In this case, if you divide that constant by one of the variables, you'd get the other variable. For instance, y would equal k divided by x. Let's say the product of x and y is 30. Well, in that case, if you have y equal to 3, x would be 10. If y is 10, x would be 3. And if y is 6, x would be 5. And you divide the constant by one of the variables to find the other variable. You'll also encounter combination and permutation problems. Now, permutation is where the choice is affected by previous choices. Let's look at a permutation problem. You're asked to assign a number to 5 different desks. You can use any one of digits 1 through 9, but you can't repeat any of them. How many combinations are possible? Okay, you have 9 possible digits to use for the first desk. Since you've used that number, you can't repeat it, so you only have 8 numbers left for the second desk. Since you will have used 2 numbers now, you now have 7 choices. So to work it out, it's 9 times 8 times 7 times 6 times 5, which gives us 15,120 possibilities. With the combination problem, the previous choice has no impact on the outcome. It makes no difference in the outcome you're looking for. In this case, the student council has been asked to determine the order for 5 bands to appear in the Battle of the Bands. And we want to see how many total combinations they have to choose from. Well, this is a completely random event. Since it's completely random, we can use the factorial mathematical operation. In this case, we have 5 bands. So it's a random order, and we can use the factorial of 5. So 5 factorial is 5 times 4 times 3 times 2 times 1. So we have 120 possibilities for these bands.